Hi, I'm Chonglai San and I'm come from Group 5.
Hello everyone, I'm Anthony Shiliyuan. Today I'm going to present MOOC 3 Question 5 Part B.
Hey guys, I'm Jack. I'm responsible for the Question 1C from MOOC 4.
Hello, I'm Ho Tong. I'm from Group 5.
Hi, I'm Ho Shi from Group 5. Today I'm going to solve Question 5A.
I'm going to present MOOC 3 Question 5A. The manager of a factory claims that the average weekly loss of man-hours due to accidents after the implementation of an industrial safety program is not more than 20. A random sample of 30 which is selected after the implementation of the program, and the mean and standard deviation of weekly loss of man-hours due to accidents are 27 and 6 respectively. Test for the manager's claims at 1% level of significance. Let mu be the average weekly loss of man-hours. The first step, we have to formulate the null hypothesis, which is mu is equal to 20. And then we have to formulate the alternative hypothesis, which is mu is bigger than 20. And we can know that the alpha is 0.01. Since the sample size is 30, which is less, this test should be used. From the alternative hypothesis, it is a one-tailed test. According to the table of standardized normal distribution, we can know that this 0.01 is equal to 2.33. Therefore, we can know the critical region, which is C is bigger than 2.33. And we can compute the value of the test statistic. According to the formula, the C is equal to 6.39. Since 6.39 is bigger than 2.33, it is in the critical region, so the null hypothesis is rejected. Therefore, the hypothesis that mu is equal to 20 is rejected at the 1% level of significance.
As for Part B, we've got the mean, standard deviation, and sample size from the table. So the question is to test whether the mean concentration of suspended particles in District A is less than that in District B at a 1% level of significance. Let XA, XB be the concentration of suspended particles in District A and B, respectively. Then assume XA and XB are normal distributed with equal variance, and random samples are selected with replacement or from infinite populations. Then step 1, null hypothesis. Mu A equal to mu B. Step 2, alternative hypothesis. Mu A less than mu B. Step 3, level of significance to be used, alpha equal to 0.01. Since the population variances are unknown and sample size are small, we use t-test, and it's a one-tailed test. Then we got critical region t less than -2.473 and degree of freedom equal to 27. Step 5, find the test statistic. Since we assume that variance A equal to variance B but unknown, so we could use follow formulas. Then let's find SP squared, which is 736.21. Then we got test statistic, which is -0.8686, and out of reject region. Then we make a decision, accept null hypothesis. Final step, draw a conclusion. Accept null hypothesis and conclude that the mean concentration of suspended particles in district A is equal to district B at 1% level of significance.
For question 1C, this is the question 1 information. If more than 40% of families in this particular district have a monthly income above 25,000, the group decides to open the new retail store. Test at 5% level of significance whether the group should open the new retail store in the district. Estimate the proportion of families has monthly income above 25,000. P hat will be equal to 30 times 29,999.5 minus 25,000 and divided by 29,999.5 minus 19,999.5 plus 18 plus 17 and plus 9 and over 140 which is equal to 0.4214, and the null hypothesis will be P equal to 0.4 and the alternative hypothesis will be P bigger than 0.4 and the alpha will be equal to 0.05. Since the sample size is 140 is large, a z-test should be used. Also from the H1 we should use a one-tailed test. According to the C table, we can find out C 0.05 is equal to 1.645 and the critical region is C bigger than 1.645, and based on the formula on the right hand side, we can find out C equal to 0.421417857 minus 0.4 and divided by the square root of 0.4 times 1 minus 0.4 and over 140, and which is equal to 0.5173. Since the 0.5173 is smaller than 1.645, so it is not in the critical region and do not need to reject the null hypothesis.
I'm going to present mock 4 question 4C. In order to test whether a special training program is effective in increasing the sales made by the salesman of a large printing company, the following data are collected concerning the weekly sales in $1,000 of 10 randomly selected salesmen both before and after attending the training program. Assuming the populations are normally distributed, does the program effective at 2.5% level of significance? First, let mu1 be the mean of the sales before attending the training program. Let mu2 be the mean of the sales after attending the training program. The null hypothesis is mu1 minus mu2 smaller than 0, and the alternative hypothesis is mu1 minus mu2 equals to 0. The alpha is equals to 0.025. Since we assume that the population of difference to be normal and the sample can be paired, a paired difference t-test should be used. From null hypothesis, we should use a one-tailed test. V equals to 10 minus 1 equals to 9. So the t 0.025 is 2.262. The critical region is t smaller than negative 2.262. We find that the mean of the difference is 0.64 and the standard deviation is 1.862. The test statistics is t equals to negative 0.64 minus 0 over 1.862 over the square root of 10. And the answer is negative 1.0x910. Since negative 2.262 is smaller than negative 1.0x69 and negative 1.0 X69 is not in the critical region, so null hypothesis is not rejected. Therefore, the hypothesis that the program is effective is not rejected at a 2.5% level of significance.
It is claimed that the mean daily expense per tourist in Hong Kong is at least 2,000 HK dollars. To test this claim, a random sample of 100 tourists is interviewed. Would you agree with this claim if the sample shows a mean daily expense of 1,850 HK dollar with a standard deviation of 500 HK dollars? Use 1% level of significance. To solve this question, firstly we have to formulate the null hypothesis, since null hypothesis is currently a accepted fact, which is mean equals to 2,000. Secondly, we have to formulate the alternative hypothesis, which is mean is smaller than 2,000. Therefore, we could know that this is an one-tailed test. As given in the question, the level of significance is 1%. Later on, we will use this figure to find out our critical region. So since the sample size is larger than 30, so we will refer to the Z table instead of the T table. We are going to look up the alpha level of 1% in the Z table because we need to find out the Z score of the boundary. According to the table, we can see that the value of the Z score is approximately 2.325. And since the alternative mean is smaller than 2,000, so this would be the bottom tail, and therefore the critical region would be Z smaller than negative 2.325. Lastly, we have to find out the test statistics, and here we would apply the formula because the standard deviation is known, so basically we could just plug in the value given in the question. The test statistic for this question would be -3. Given the fact that the test statistics falls in the critical region because -3 is smaller than -2.325, so we could reject the null hypothesis and accept the alternative hypothesis.